Number 109. Draw the Lewis electron dot structures for these molecules, including resonance structures where appropriate. And then we have CS2. So we have to draw the Lewis structure and then the resonance structure if appropriate. Now the Lewis electron dot structure is basically just saying we got to cover all our bases. We got to put the dots in there for the electrons and we have to show the bonds. And then we'll see if this molecule has a resonance structure. But you can't figure out resonance until you have that Lewis structure drawn. So that's the first thing we're going to do here. Now in this case, for all Lewis structures, the first things first is try to draw your blueprint, and remember the lowest electronegative element goes in the middle. So carbon goes in the middle, surrounded by the two sulfurs. So 1 and 2. Now in order to draw the Lewis electron dot structure, always take it from the valence electrons. Right? Carbon is in group 4A or 14 on the periodic table, so lucky number 4 for carbon. That means that carbon has 4 valence electrons, so I'll draw 4 dots. And the sulfur is in group 6A or 16, so lucky number 6. So each sulfur has 6 valence electrons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And now we always single bond first and then check for the octet. We only do multiple bonds if we need them. But let's just see if we could get away with single bonds. So dot to dot always makes a bond. And dot to dot is a single bond. So now check those outer elements. Does this sulfur have an octet? 2, 4, 6, 7. Ooh, this one looks super close, right? If we could gain this 1 dot, sulfur would be super happy. So sulfur says, can we please share that 1 electron? I need it. And carbon says, for sure. So there's the double bond. And now the sulfur is happy. 2, 4, 6, 8 electrons. The same thing goes for the sulfur. 2, 4, 6, 7. This one's looking nice. Sulfur says, well, I mean, sulfur's more electronegative. So sulfur is going to be like, give me this. I need that. But carbon says, sure. So we bond it up. And sulfur, 2, 4, 6, 8. It's got the octet. And carbon, 2, 4, 6, 8. Everyone's happy. This is the Lewis electron dot structure. Now, does this structure have any resonance structures? Well, a resonance structure just means that you have delocalized electrons. So there's localized electrons in chemistry and delocalized electrons. Local, if you're staying local, you're not, going out to, different towns or cities. You're staying local, right? So localized electrons stay put with their atoms. Delocalized means that you're going to other atoms. Now we can see that we have delocalized electrons if we have the same atoms around the central atom, which we do here, right? We have 2 sulfurs, but do we have different types of bonds? No, right? They're both double bonds. So even if I took this and swapped it with the other one, the molecule would be identical, right? You wouldn't know the difference. I wouldn't know the difference. So for this one, since you have 2 double bonds with the sulfurs on the end, there are no delocalized electrons. They're just going to stay put with their atoms. It's easier to stay put than try to, move, because it's the same thing. So it doesn't really matter. What was I going to say? The resonance structure would kind of look like if you had, let's pretend that this one didn't exist. And then you had a double and a single bond. Then if you change them, that would be resonance. But we have both double bonds here, so no resonance for this one. And that's the answer. So you only got 1 Lewis structure for this guy. All right? I hope this helped. Let me know in the comments. Love talking to you guys. I hope you're having a great day out there. Keep studying hard. Always keep learning, not only in chem, in physics, math, foreign language, history, whatever you guys are taking. Good luck on your tests and quizzes, and I'll talk to you later. Bye-bye.